Hello and good morning students, and welcome back to Mehta PG College online study portal. And today in this video, this is the lecture 7th recorded for BSc first year physics for the paper first mechanics, although it is the unit first but the chapter 2nd. Today in this video we will enhance our knowledge by taking some numerical examples into consideration. In this video we will talk about that how and how much does the Coriolis force takes its impacts on the bodies which are at rest or which are in motion. So let's talk about that what is the condition of extreme rest and what is the condition of extreme motion. So relating to them, we got some numerical examples here in which we will talk about that how does the action force and the reaction force both acts on a single particle system and how does the results came out to be. Okay, so before starting the video, I would like to request you that if you are new here, then consider subscribing our channel and press the bell icon, because this is a free study portal not only just for the Mehta PG College students but everyone of who is interested to know about the physics, how does the things relates to us. This is a free study portal for everyone, for every student. So consider supporting us by subscribing this channel and give us a thumbs up, so that your appreciation will lead us to confirm that we are providing you more entertaining and more enhanced learning concepts day by day. So let's begin with the topic here. Let's talk about some numerical examples. We will talk about only those most important numerals which are important according to your exam point of view. So let's begin with the video here. Okay, so by starting, the question being asked saying that we are subjected to determine the effective mass. Yes, determine the effective mass, and effective mass of which the effective weight of an astronaut of 60 kg, well not the mass here but the weight, the effective weight of astronaut of 60 kg. Well, you got the difference between weight and mass. What is the difference between weight and mass? In real sense, your mass is constant. Your mass is a universal constant. Mass will not vary from planet to planet or from one position to another. There is no variation in mass. But the thing change is, which is called as the effective mass. And in sense of gravity, when you are being attracted by the earth and or being attracted by a heavy body, then something is taken into consideration which is the weight here. Okay, so that is the difference between weight and mass. So we are subjected to find out the effective weight of an astronaut who has a weight of 60 kg already, and what is the condition next is when its rocket is moving vertically upward from ground with acceleration 6g. Okay, his rocket is moving vertically upward from ground with an acceleration 6g. G here stands for, G is here that stands for the gravitational acceleration, and the 6g means that it is moving 6 times than the gravitational pull. The gravitational pull, you know, which is the 10 meters per second, approx 9.8 meter per second the actual value, and in approx sense you can say that it is 10 meter per second. So you can say that it is moving the 60 meters per second must be the minimum velocity at which the rocket is moving upward. So what will happen? You remember the concept of pseudo forces which we have talked for the very first lecture of this chapter. We have started with the pseudo forces there. So we got a concept of moving lifts. Okay, when the lift is going upward and you are inside, you will feel limited for a short time period. You will feel that your weight keeps on increasing. But when the lift is going downward, you feel sometimes it's light. It's lighter than usual. Okay, so that's all what happens here. And the same thing is related here, about which we are talking right now. Okay, so let's solve this example and find out that what is the concept of effective weight here. So for solving this, we got some value saying that the mass of astronaut, let's say denote it by m, that is equals to, that has been given 60 kg. 60 kg is been given to us. Sorry. And the acceleration of rocket is been given 6g meter per second. Okay, so these things are given. So what should be the effective mass by now, or the effective weight? Effective weight, that will be equals to m into g plus a naught. So what did we use here? We just use the concept of, here a naught is the acceleration, this is the acceleration which is a naught here, and g is the gravitational acceleration. So we got the concept of effective mass by applying the pseudo forces. You know that the force, if you are moving upward and when you are moving downward, so what is the actual concept working on you? The thing that is working on the astronaut is, when he is going upward, then some certain force is pulling him downward. Okay, let's say he is the astronaut here who is moving upward, then surely when he is moving upward, some forces are there which we have termed as the pseudo forces are pulling him downward. These are the forces, the pseudo forces which are pulling him downward. So in this sense, what it is actually, in the pseudo forces concept, the person is being pulled downward, so certainly some sort of acceleration is working on him, so we termed it as a force. And we can say that in sense of this force, the weight will be effective here. This force will be equals to the effective weight, you can say that. Because this pull, this is the pseudo forces pull, this pull is working on every single weight particle there, every single massive particle. The pseudo force is working on every single massive particle. Here the word, here the term massive doesn't mean to something that is bigger, but the term massive means that every particle that has some sort of mass. Saying even the infinite small mass, then there is no use of this term, but every single particle that has a considerable mass. So I termed that here as a massive particle. Okay, the massive particle means every particle that has a considerable mass. Considerable mass in sense of this 60 kg. Okay, like say that if something get weight like that 6 microgram, so I am not taken into consideration that, but if something that has weight about 60 grams, 100 grams, 200 grams, then it is a considerable weight, okay, or the considerable mass here. So this force, these are the forces which are working on every single massive particle. The massive particle means the particle that has a considerable mass. So what we end up having, this effective weight must be equals to this force, and you know that force is equals to mass into acceleration. Okay, so what is the mass? Mass we have taken into consideration, that is m, already been taken as the 60 kg. Okay, and what would be the acceleration by now? The rocket is moving with the speed that is equals to the 6g. Okay, the rocket is moving upward with a speed of 6g, and you know that gravitational pull acting will be given to addition to it, because this time the pull is beside the gravity, we are not towards the gravity. When going towards the gravity, this term can be written as the minus g, but when you are in negative sense, so the minus g again got a negative sign, and negative negative will become positive here. Okay, so that's why the effective weight will be equals to mass into g plus a. What is the g here? G is the gravitational acceleration. So let's put all those values, and what we will have, let's see, that is the 60 kg. This is the 60, which is the m is the 60 here. This m is the 60 plus m into g. Well, that is equals to 6 grams some weight plus 60 into 6g. This is g here, 60g plus 60 into 6g. Okay, so let's solve them. What we have? We will have a value that is equals to 420 g newtons, and Newton is the unit that is being used for the force here. Okay, so that is the 420 g newton. So rewriting this term into weight, saying that that will be equals to 420 kg weight. Okay, the force can be defined in terms of mass there or in terms of weight here. Okay, so that is the effective weight. So the astronaut who is inside the rocket, which is moving with a speed of 6g with an acceleration, not a speed actually, because it is keeps on accelerating. The acceleration means the velocity is keeps on changing. Acceleration is not a constant term, keep it in mind. When the velocity is constant, then there is no acceleration. Acceleration will only exist when the velocity will keeps on going, will keeps on changing. Either it has been increasing or it has been decreasing. Okay, in that time the acceleration will exist, otherwise there will be no acceleration. Okay, there is a term here. So let's move towards another example, and that is again a most interesting example, I think, that because it is the example of Coriolis force that we have talked about in the previous lecture, saying that for the lecture 5th, in the lecture 5th where we have taken into consideration the effect of Coriolis force on bodies which are falling vertically downward. So this is the same kind of question here, and let me see the question, and we will take it into the brief and talk about the question here. The question is being asked as a body falls from a height 200 meter. Yes, there is a body. Body falls from a height 200 meters at a place where altitude is 45 degree north, where altitude is 45 degree north. You remember what is the altitude? If we got the you know the term which has been said as the lambda which is equals to the latitude, and altitude means something that is being tilted towards. When you are going to watch from the center, then it is latitude, and when you are going to get it from the point where it is, then it is called as altitude. Okay, so this is the altitude here. Well, altitude means you got two terms saying that the altitude lines and the, I don't know the exact term, sorry. Let's begin with the example here. Find the eastward deviation of body with respect to the place directly below due to rotation of Earth. We are subjected to find out the eastward deviation. How much does the body will go towards east? Okay, so let's find out that what should be the body will going into the direction. Let's begin with the example here. Let's start in solving, And whenever you are going to solve any numerical, if any numerical is being asked in the exam and you are subjected to come up with its answer, and I don't think so that every time we got a clear answer for our question, then you just subjected to come up with some things like as the starting the example. Okay, you must go and start with it. Let's talk about what has been given to us. What are the things that are being given? Given us the height is equals to 200 meter, HEIGHT, height of the tower is been given 200 meters. Okay, angle of latitude is been given, that is the lambda, angle of latitude. That is, you say, is lambda, and that is been given as the 45-degree north. North means in the northward direction. Okay, this is the east here, this is the north here. Okay, you remember that in this concept, what is the 45 degree? This is the 45 degree. Okay, that has been said, and the 45-degree north. Okay, we are raising from east and going towards north. So that is the 45-degree north. I hope that you got it. Okay. Also, there are some things that we know ourselves. So what is one more thing is here, if lambda is equals to this, then you can say that cos of lambda that we are going to use in our example, in our solution here, then cos of lambda will be equals to 1 over root 2. Okay. So these are the basic things that are being given to us, and we are subjected to consider ourselves. Okay. Altitude is been given, the height has been given. So something we are going to talk about the eastward deviation, and you know that eastward deviation is because of what? Why does every falling body got a deviation? That is all because the earth is keeps on rotating. Okay, the earth is keeps on rotating, and when any body that is been rotating, every time the rotation is due to every time the rotation has some associated term with this, that is the angular velocity. So when we are talking about the earth here, so we just have to know something like saying the terms like the angular velocity of earth. Okay, we know that, here it is, we know that angular velocity of earth. Angular velocity, let's say, that is been denoted by omega, and omega will be certainly a vector quantity. You cannot say that it has been saying as a scalar quantity. So what should be the value here? 2 pi, there is a total rotation, displacement upon time, and time is 24 hours. When you are going to solve the things like 2 into 3.14, because we are talking about the radians here. Okay, that's why I wrote here 3.14. Otherwise, when we are talking about the degrees, then for degrees what we will do? We will say that 2 into 360. Okay, but we are taken into consideration only the radians, because we have distance in meters, not in degrees. Okay, that it is. 24 hours are been termed in the terms of second, 60 into 60. So what should be the value here? Well, this is a scalar value, because we are taken into consideration only the radian part here. We just need a numeral value. So what should be the value of omega by now? If you remember that the value of omega is equals to 7.29 into 10 to the power minus 5 radian per second. 7.29 into 10 to the power minus 5 radian per second. Okay, that will be the value by now. 7.29 into 10 to the power minus 5 radians per second. That is the value of omega. So now let's find out the eastward deviation, and to finding the eastward deviation, what we are subjected to come up with, we just go to the ground and we will use the simple formulas that has been answered by us, that has been calculated by us, saying that horizontal displacement of stone on the ground. Horizontal displacement of the body on the ground. Okay, what should be the horizontal displacement? Let's say this is the x dash is the new coordinates, and that will be equals to 1 by 3 omega g cos of lambda, omega g cos of lambda, and into 2h over g power 3 by 2. So what should be the value of x dash by now? The value of x dash will be here, the value of x dash will be 0.044 meters. 0.044 meters. Okay, so that will be the value of deviation. So you know that in which direction it has been said that the object is been moving to the westward direction, and we are subjected to come up with the answer that how much the deviation will be. So the deviation will be 0.044 meters. So it means that this is not a larger displacement. I cannot say that if it is a thing is been thrown this way, so it should get a displacement about this. Okay, this will be like that, this much distance only, not very much. Okay, so that would be the value here. This is not only a single meter, this is about 4 centimeters only. So 4 centimeter is that much distance. Okay, so that much will be the displacement here. I hope that you got the concept here. You just keep it in mind that you are subjected to come up with these formulas into your mind. Well, this is not so much important, but somewhat these types of question may be asked into your exam. So what you will end up with. So that's why we are discussing these numerical examples, just because we just wish to enhance our knowledge with these examples here. And let me be aside, you can take a screenshot for your reference, and then we will proceed for a new example. Okay, I hope that you are done with the example here. So now we have one more important example that is pretty much important than the examples we have discussed here. That is the example of a bullet that has been fired from a gun. Okay, so let's find out what we have here. Okay, so it has been said that for this example, a bullet is fired horizontally towards north with a velocity of 500 meters per second. We are just going to take into consideration these things here only. The velocity of the bullet, let's say this is V here, that is equals to 500 meters per second. Also this has been said that this velocity is towards the north direction, and you say that when we are going to talk about the north direction or the eastward direction, then we will go through some axial representation, one of which is the x-axis and the another one is the y-axis. So where does the north falls on which axis does the north falls on? North falls on the y-axis, and the y-axis has some associated unit vectors that are saying as the j cap. Okay, so the j cap will be the unit vector associated. So in vector form, let's say if it is the v vector here, so what you can say that this is 500 meter per second will have a direction saying that the j dash cap, okay, 500 j dash cap meters per second. Okay, this is the j dash cap here. Okay, so within 1 second the bullet is being traveled 500 meters distance, and going towards the northward direction. So we got the velocity here. Yes, this is the velocity here, velocity of bullet. Also we have given the angle of latitude is 30 degree. Okay, so the angle of latitude, that is the lambda, and angle of latitude, that is lambda. And lambda is equals to 30 degree. Okay, what we are subjected to determine the horizontal component of Coriolis acceleration acting on the bullet and the displacement when bullet strikes the target placed at a distance of 250 meter. This is the velocity here, and for the half of the second when the bullet has been travelled a distance of 250 meters, so what should be the horizontal component of Coriolis force that is being acted upon the body, so that the body is being get a displacement when after 200 meters when it strikes. So what should be the displacement there? Okay, so we were going to talk about some things like as the angular velocity of earth, because we need it. And you know that angular velocity of earth is equals to omega is equals to 7.29 into 10 to the power minus 5 radians per second. Well, this is a universal constant value. You can remember it yourself, because this is the most important value. I hope that you can got it. Also, the Coriolis acceleration, you remember what is the value of Coriolis rotation here? The Coriolis angular velocity, that has been said that omega vector, and this omega vector is equals to the angular velocity of earth is given by omega vector is equals to j dash cap omega cos of lambda, omega cos of lambda plus k dash cap omega sin of lambda. The cos of lambda is means that the vector associated within the axis, and the sin of lambda means that it has been associated with the direction perpendicular to the axis or the line of action. Okay, so this is the omega vector here. Okay, so we got these values here, and we get the you remember that the mass of bullet is also been given here. The mass of bullet is been said that 100 grams. Okay, mass of the bullet that has been said, this is m. Sorry, m is equals to 100 grams, and you can say that that is equals to 0.1 kg. That is equals to 0.1 kg. This is the mass here. Okay, so these are the values which have been given here, and let's talk about the Coriolis acceleration acting on the bullet. Now the Coriolis acceleration. Acting on the bullet. All of these terms are given to us. Okay, these are the above terms which have been given to us, or we know them. Okay, this is the only thing. This is the thing which we are subjected to calculate here. Let's write the Coriolis force, Coriolis acceleration, that is equals to the Fc here, and you remember that is equals to omega cross v. I hope that you remember the result. This is the Coriolis acceleration, and that is been written in the terms of small f here. So let's substitute all these values, and that is equals to the -2 here. There is a -2 here. So substitute the values here. What we will have, this Fc is equals to -2 should be taken outside, and that will be again a vector quantity. The value of omega, that is equals to j dash cap omega cos of lambda plus k dash cap omega sin of lambda. Okay, and